We're going to be going over the AI 900 module that covers generative AI and agents inside of Microsoft Foundry. Generative AI is a rapidly growing area of artificial intelligence focusing on creating new content such as text, images, video, and code. In recent years, generative AI has significantly transformed how people work and build technology. This module introduces a framework for understanding generative AI applications and explores how Microsoft Azure AI and Microsoft Foundry support the development of these solutions. Common generative AI use cases: marketing, content creation. Generative AI tools such as Microsoft Copilot help organizations automatically generate product descriptions, blog posts, and social media content, improving efficiency and maintaining brand consistency. Customer support. Businesses deploy AI-powered virtual agents that understand natural language and provide 24/7 automated customer support. Code generation. Tools like GitHub Copilot assist developers by generating code suggestions, functions, and entire modules from natural language prompts. Image and video generation. Creative professionals use models from the Microsoft Foundry model catalog to generate visual content from text prompts. Personalized learning. Educational platforms use generative AI to create custom learning materials such as quizzes, explanations, and study guides tailored to individual learners. The key focus of the module is to explore the tools and platforms Microsoft provides for building generative AI applications, particularly within the Microsoft Azure AI ecosystem and Microsoft Foundry. Generative AI enables applications that create new content and automate creative or knowledge-based tasks. And Microsoft provides tools like Foundry, Copilot, and Azure AI services to support their development. Understand generative AI applications. Generative AI applications are built using language models, which provide the core logic for generating responses and interacting with users. These applications often appear as assistants or agents that help users complete tasks or access information. AI assistants. Assistants are generative AI systems that interact with users through chat-based interfaces. An example is Microsoft Copilot. Capabilities include answering questions, generating content, automating tasks, and providing a real-time productivity assistance. Developers can extend assistance by creating plugins or integrations that connect them to business systems and data. AI agents. Agents are more advanced AI applications that can take actions and complete tasks automatically. Example of tasks that an agent might perform is scheduling meetings, booking transportation, or completing multi-step workflows. Agents include three main components: the language model that handles reasoning and language understanding, the instructions that define the agent's goal and behavior, and the tools that are the external functions or services used to perform tasks. AI orchestration. Modern AI systems often combine multiple components such as language models, data sources, APIs and tools, and workflows. Managing how these components work together is called orchestration. Generative AI applications can be grouped into three categories: ready-to-use applications, no development required. An example is using Copilot to ask questions or generate content. Extendable applications, which are pre-built tools that can be customized with business data. An example is extending Microsoft Copilot. And custom-built applications, where developers build assistants or agents from foundation models. Microsoft provides tools to develop generative AI applications, including Copilot Studio, which extends Copilot with custom functionality, and Microsoft AI Foundry, where you can build custom AI solutions using various models. Generative AI applications use language models to power assistants and agents and can be ready to use, extendable, or fully custom built using AI platforms like Microsoft Foundry. Understanding generative AI development in Foundry. Microsoft provides a broad AI ecosystem for building generative AI applications. One of the key platforms is Microsoft AI Foundry, designed for developing, customizing, and managing AI applications and agents. With Foundry, developers can deploy and customize language models in the cloud and integrate them into applications and services. The core components of Foundry include the model catalog, which is a central location to discover, compare, and deploy AI models, and includes foundation and partner models used for generative AI development. Foundry tools, pre-built AI services that can be tested, demonstrated, and deployed within applications. Solutions, which are tools for building AI applications and customizing models to fit specific business needs. And observability, monitoring capabilities for tracking model usage, performance, and system behavior. Microsoft Foundry is a developer-focused platform that provides greater control over models and infrastructure and is used to build custom AI applications and agents. While Copilot Studio is a low-code development platform designed for building conversational AI experiences, it is delivered as a fully managed SaaS solution and integrates with Microsoft 365 and tools like Microsoft Teams. Microsoft AI Foundry is a cloud platform for building and managing generative AI applications, offering model catalogs, testing environments, development tools, and monitoring capabilities for enterprise AI solutions. Microsoft Foundry's model catalog is a centralized marketplace that provides access to a wide range of AI models from Microsoft, partners, and the developer community. Developers can use the catalog to discover, compare, test, and deploy models for generative AI applications. Microsoft's Azure OpenAI models in Foundry are considered foundation models. They are pre-trained on massive datasets, can perform general tasks immediately, and can also be fine-tuned or customized for specific use cases. Because they are already trained, these models can often be deployed directly to an endpoint without additional training. If a model needs to perform better in a specific domain or task, developers can customize it by fine-tuning with domain-specific data and integrating organization-specific knowledge, which helps improve performance for specialized scenarios. Foundry provides tools to help developers choose the best model, such as playgrounds, which allow you to test prompts and experiment with different models, model leaderboards, where you can compare models based on metrics such as quality, cost, and throughput. Visual comparisons help developers evaluate trade-offs between performance, speed, and cost. The Foundry model catalog enables developers to discover, test, compare, and deploy foundation models, and optionally customize them for domain-specific generative AI applications. Microsoft AI Foundry organizes development using hubs and projects which help structure AI resources and development workflows. A hub provides broad access to Azure AI and Azure machine learning resources, creates supporting resources automatically such as Foundry tools, and access the central environment for AI development. Whereas a project is created within a hub, it's used for model experimentation, application development, and agent creation, and provides focused access to models and tools. Projects can be managed from the Foundry overview page. Foundry includes several pre-built AI services, such as Azure Speech, speech recognition and text-to-speech, Azure Language, text analysis and natural language processing, Azure Vision, image analysis and computer vision, and content safety, which detects harmful or unsafe content. These tools can be tested through interactive demos and playgrounds. Foundry provides playgrounds to experiment with models and AI services. Examples include Chat Playground for testing conversational models, and Model Playgrounds for experimenting with prompts and outputs. Playgrounds allow developers to prototype AI solutions quickly before deploying them. Generative AI models can be customized in several ways. Grounding data, connect the model to reliable data sources such as databases or knowledge bases, and improves accuracy and trustworthiness. Retrieval Augmented Generation, or RAG, retrieves relevant information from external datasets before generating responses and helps produce up-to-date, context-aware answers. Fine-tuning, where you train a pre-trained model further with task-specific data and improves domain-specific performance. And security and governance controls, where you manage authentication, access control, and data protection. This ensures responsible and secure AI use. Microsoft Foundry enables developers to build and customize generative AI solutions using hubs, projects, AI tools, playgrounds, and techniques like grounding, RAG, and fine-tuning, while maintaining strong security and governance controls. Observability refers to monitoring and evaluating the performance, quality, and safety of generative AI systems to ensure reliable output. In generative AI, evaluation typically focuses on three main dimensions. Performance and quality evaluators measure how accurate, relevant, and grounded the AI-generated responses are. Risk and safety evaluators identify potential content risks such as harmful, biased, or inappropriate responses. And custom evaluators, which are industry-specific metrics designed to evaluate application-specific requirements or goals. Microsoft Foundry provides built-in evaluators to monitor AI systems and improve trustworthiness. Examples include groundedness, measures how well responses align with the provided context or retrieved data. Relevance evaluates how closely the response matches the user's query. Fluency assesses natural language quality and readability, and coherence measures logical flow and consistency of the response. Content safety detects harmful, unsafe, or policy-violating content. Observability in Microsoft Foundry uses evaluators to monitor generative AI performance, safety, and reliability, helping ensure responses are accurate, relevant, coherent, and safe. The exercise from this module: get started with generative AI and agents in Microsoft Foundry. In this exercise, you use Microsoft Foundry to deploy and interact with a generative AI model and explore how chat-based AI applications are built. Step 1, we created a Foundry project. Our project configuration includes Foundry resources, Azure Subscription Resource Group and Region. After creation, the model is deployed to the project so it can be used by applications. Step 2, use the Chat Playground. The Chat Playground is a testing environment for building and experimenting with generative AI chat applications. Key components include the setup pane, select the deployed model, and configure system instructions. Chat history, enter prompts, view generated responses, and maintain conversational context. An example of this is you are an AI assistant that helps people find information. 3, we tested the generative AI prompts. We interacted with the model using several prompt styles. Basic prompt, ask for travel help to Paris. Contextual conversation, ask for places to stay in the city. The model remembers the context, which is Paris. Iterative prompts, ask for dining options near a previously mentioned location. Grounded prompts, provide a source to guide the response. Reasoning prompt, ask the model to recommend locations and explain reasoning. And structured output, request a numbered list of top attractions. These examples demonstrate prompt engineering techniques such as context retention, grounding, clear instructions, and structured outputs. Next, we view the client code. The view code feature provides sample code for integrating the developed model. The view code feature provides sample code for integrating the deployed model into applications. Examples are available for multiple programming languages, different SDKs, and various authentication methods. This allows developers to quickly build apps that call the model's API endpoint. Using Microsoft Foundry, developers can deploy foundation models like GPT 4.1, test prompts in the Chat Playground, build chat-based AI applications, and access sample code to integrate models into real applications. The module assessment. Question 1. Which of the following best describes the role of a generative AI agent? With the answer being an application that can understand input, reason, and take actions automatically. Question 2. Which of the following best describes the purpose of the Microsoft Foundry model catalog? With the answer being it is a centralized hub for discovering, comparing, and deploying models for generative AI. Question 3. What is the purpose of fine-tuning in the context of generative AI? The answer being it involves further training a pre-trained model on a task-specific dataset to make it more suitable for a particular application. In summary, in this module, we learn that generative AI applications are powered by language models, which serve as the core logic behind user interactions. These applications often appear as assistants or agents and can be categorized based on the level of customization required, from ready-to-use tools to fully custom-built AI solutions. You also explored Microsoft Foundry, a unified playground for building generative AI applications. Foundry provides access to a large model catalog, playgrounds for testing models, deployment tools, and observability features to monitor AI performance. Additionally, you learned how developers can use Foundry tools and APIs to integrate AI capabilities into applications and build intelligent, scalable generative AI solutions. And that was the module from the AI 900 path in Microsoft Learn, where we learned about generative AI and agents inside of Microsoft Foundry.